Garage Science.
Hey guys, on this episode of Garage Science, I have Cole helping us out today. So the first part of today's assignment is we have a quick review. Okay, as we go into this new unit of reaction rates, I just want to go back and review how heat is transferred in a reaction. If you remember way back, like beginning of the year, way back, we worked with heat and we explored how heat and energy transfer to the molecules in the reactions that we were studying at that time. Now, there's two types of reactions in terms of heat. The first type of reaction is where heat is released and feels warm, which is called what, Cole?
Exothermic.
Exothermic, right? So exo means out, right? And then the other type of reaction where heat is being absorbed and feels cold to the touch is called what?
Endothermic.
Endothermic, that's right. We talk about heat in terms of the vocabulary term is enthalpy. So enthalpy means heat. And if you remember way back when we were doing this stuff, we did see some special types of diagrams for endothermic and exothermic enthalpy, right? So below, the next part of this quick review is to sketch out those two types of enthalpy diagrams, exothermic and endothermic. The next part of our lesson involves reaction rates. So that's what our next unit is about. It's about how fast or how slow reactions take place. Okay, so the first thing that there's lots of different types of reactions, and the first type of reaction we want to think about is, can you think of some examples of reactions that start immediately but take some time to finish? Like around your house. So, Cole, what might be a type of reaction that would start immediately but take some time to finish?
Lighting a burner.
Okay, so lighting like a burner to on your stove. Okay, what's another example?
Burning wood in a fireplace.
Okay, so if you have a natural fireplace, if you start a fire with wood, or even if outside, if you start a wood fire, it starts pretty immediately, but then takes a while to complete. Right? Third example would be like an Alka-Seltzer tablet. Right? So as soon as you drop it in the water, it starts fizzing, creating that carbon dioxide gas, and it takes a little bit to finish. Okay? Now, some other types of reactions that happen around you all the time are reactions that start slow and continue slow. So what's a real good example of that, Cole?
Rusting.
Rusting, for sure. Right? Rusting is something that just happens over time. It's not something that we can sit there and watch happen. Okay, but I got a clip here that shows it over time that you can watch real fast.
Some reactions take more time than others. Iron nails react with oxygen slowly, producing rust over a period of months.
Slow reaction is called sun bleaching. So you can see here on my barbecue cover, the Velcro straps, they used to be black, but over time, from sitting in the sun, they've turned whitish, and actually the Velcro itself even has worn out and has become useless. The third type of reaction, or style of reaction, is reactions that we purposely speed up or slow down. What's a good example of something that we speed up or slow down, Cole?
The stove.
Okay, and what do you do on the stove? Okay, so cooking. So cooking is a pretty good example of how we speed up reactions. Okay, so if you see an egg on a frying pan, the white part or the clear part becomes white, and that's a chemical reaction. You can't turn it back to something else. You changed it, right? And what's another really good thing that we all have in our house that slows down reactions? If you don't want your food to go bad, where do you put it?
A fridge.
A fridge,
Or a
right?
freezer.
Okay, or a freezer. So if you want your food to last a long time, then you want to put it into a fridge or a freezer, because that slows down the decomposition reactions in the food. Okay, another type of reaction that we control is probably something that's more more interesting to all of you as you're getting your licenses and starting to drive, and maybe not so much right now, but a car engine, a good old internal combustion engine, 100-year-old technology. You know, we walk around with phones in our pockets and we still drive around in the same concept of an engine that's been around for over 100 years. So anyway, Cole, why don't you grab those keys right next to you in the cup holder, put it in the ignition. So this is twofold here. Cole's getting a lesson, and so are you guys. All right, just turn it so it fires up all the way. Keep going. All right. Okay, so the car engine's running, and if Cole gives it some gas, do it again, buddy. All right. So Cole gives it gas. By him giving it gas, he is controlling that reaction.